Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, it's actually a video about the Plexus. And the funny thing is, the last video I made on this on the main channel, I said, oh, this is probably the last video I'm going to make on this. Well, we have one more. And the reason why is I want to revisit this RAM card that my friend Super SVGA made. And let's see if we can get this working in the Plexus in time for VCF. Now, in case you missed my recent Plexus wrap-up or follow-up video on the main channel, I showed this off, and this was a prototype RAM card that, like I said, my friend Super SVGA made for this machine. He based the pinout on documentation that we found on the hard drive, and this has SRAM, level shifters, and some glue logic, a voltage regulator as well, because this is a 3.3 volt part, and these are 5 volt to 3.3 volt regulators. And yes, this should give the Plexus a full 8 megs of RAM. The Plexus P20 was designed to support up to 8 megabytes. The memory mapper that's in there, because to run Unix, you need to have a memory management unit, and it's got a mapper that's basically TTL logic with some SRAM. It can support up to 8 megs. There was an email on the hard drive from the people at the company to the designer of the computer that said, hey, one of your tasks is to make a larger RAM card. All that's in that machine right now is a 2 meg RAM card, which as far as we're aware is the only RAM card that was ever made for that thing. Well, this thing theoretically should allow it. As for whether the computer can see it or use it, if there's a firmware problem, who knows? But this card, when I tried it out in the main channel video, it didn't work. I didn't actually power on the computer because I could tell as soon as I plugged this in, there was a short on the 5 volt rail to ground. So clearly if I turned it on, something terrible would happen. So I never did. Now, I tried to fix the short by lifting this pin because I could tell that there was a ground pin and it was shorted to 5 volts, and that was compared to the original RAM card that's currently installed in the machine. And that's one of the negatives. To even test this out, I have to take the whole computer apart completely, remove the motherboard, the RAM card's on the back, and then try this out. Anyhow, I was talking to Super SVGA, the designer of this card, and Super SVGA sent me some schematics for this because I didn't have that handy. And I started taking a look at it and wondering if potentially the issue with the short is because this connector, this Euro connector, or whatever this multi-pin connector is, needs to be installed on the backside. So obviously it could go this way, we could rotate it around 180 degrees, but I think it actually needs to be on the back side of the board. And that potentially might make this work. Well, what am I talking about? These are the schematics, and there's actually the logic equations for the CPLD that's on here as well. That's the glue logic. Here are the schematics. Let's download this and take a look at the PDF. Right here is our 16-bit SRAM, the 8 megabyte one. These are pretty common, and in surface mount packages are very inexpensive. If you tried to get an 8 megabyte one in DIP, I'm not even sure that actually exists because it would be 48 pins. But the 3.3 volt 8 megabyte surface mount ones are cheap, and that's what this is. And just well, it's not much to it really. It's just these are the level shifters right here. And you can see data lines and data lines. Now DMA, job processor, there's 2 different processors on this. So I think besides level shifting, I think these also have the duty of connecting the data lines to one or the other processor. And there's some signals that come in from the main motherboard that selects which processor can talk to the RAM at any given time. So DMA is the one that handles all the I/O on the system, and then the job processor is actually what runs user processes. I think the OS runs on there as well. When the system powers up though, the only thing that's in use is DMA, and then when it tries to boot to OS, that's when the job processor comes online. This is what I think I remember correctly, but I might not be 100% correct on that. Either way, this all goes to that large connector here. It has A, B pins, and then the C pins. And the problem I saw when I was looking at this is if we take a look at these VCC pins, and there's VCC, there's ground, there are 2 ground pins as well. Well, I was noticing, and the reason why I lifted this one pin on here, that looked like the VCC, which was on 2 of these pins, was also connected to this ground pin. And that would mean, of course, as soon as I plugged this card in, it created a short. Now, even though I lifted that pin, so there was no longer that short, there were a lot of other ground signals around. And specifically, there are these right next to VCC. Now, if this pinout is correct, and I was kind of theorizing that maybe the pinout in the original documentation didn't match the actual hardware, but looking at this again, I think it actually does. And here's the reason why I think flipping the connector might actually fix it. VCC and grounds are right next to each other on these A pins. Well, the thing is, it goes from A1 all the way to A32. But if you look at where these signals are, A14, 15, 16, and 17, and 18, this means that if this connector is plugged in kind of the opposite way, like flipped onto the other side of the PCB, then what is pin 1, this MA1 signal, would actually be routed to A32 on the new RAM card. Well, that necessarily won't matter, but I did notice when I was looking at the traces on here that didn't really make sense versus the actual RAM card, because I saw a ground lead, for instance, that was going to one of the level shifters, and it wasn't the ground, it was one of the signal wires. Well, that makes sense because look, here's that ground, right, on pin 2, and if it were flipped around the wrong way, then it would actually be going to the DDMA signal that would go to one of the level shifters. And that's kind of what I was seeing. But beyond that, these VCC and ground signals are actually not exactly in the middle of the connector, right? Because, you know, it's from A1 to A32. So that means if this were flipped the wrong way, just this stuff here would also be shorting VCC and ground. So I think what I need to do is desolder this connector, take these fasteners off. There were these nuts and bolts here that hold it on, and stick it on the back side of the board. So basically flip it around. And it's going to be tedious because there's 32 times 3 pins. But hopefully this comes off relatively easily. Then I can put this pin back in. And then what I'll need to do is just put this back in the board or back into the Plexus P20 and then see if we have that short anymore, especially on the voltage regulator. It's very easy to see if you have it there. Okay, well, what I need to do is heat up the desoldering iron, and I'm just going to get busy. This is boring. I'll just do a little bit of a montage where I get this thing out of here. Okay, that is off. That was unbelievably difficult and fiddly because, you know, I don't have another one of these connectors, so I didn't want to break it. And really, it was that bottom row that just, I guess a lot of solder had wicked up onto the pins and I could not get it off. So hot air wiggling, and I don't know, it's off. Hopefully the board didn't get damaged. I don't think I knocked off any other components. So really, I just need to clean this. This thing didn't get melted either, so that's good. So now, question is, can I get this back on? Because some of these pins got kind of bent up getting it off, and this might be impossible. No, I think that worked. I don't see any pins that are bent. So what I need to do is install these fasteners here just to kind of keep this in place while I solder it on. And now the long process of resoldering all these pins and not making any shorts while I do it. All right, there's our prototype 8MB RAM card with the connector flipped around. And I did remove the programming header for the CPLD just because I think when this goes on the board, it goes on like this, and the motherboard is going to be like right here. I'm going to grab the other camera and get set up and get that Plexus opened up and pulled apart, and we'll plug this in. And before I even turn it on, I can just check to see if our short is gone. And there is a couple switches on here, which I think will disable the additional memory that's on here, theoretically. I need to ask Super SVGA about that, because if there's a firmware problem that prevents it from working as an 8MB card, then maybe this can run as a 2MB card as a start, just to see if it's wired up correctly and the logic is working, and then we can try to figure out what's going on with the additional RAM. Okay, I'm gonna get set up. Okay, Plexus is open. VT220 is turned on and connected. I haven't changed anything yet. This is the original RAM card. I just wanna make sure the computer is fully operational still. This is in the off position, I think. There we go. Let's just make sure. Okay, we're getting the Plexus banner on there, and it should start doing the self-diagnostic. Yeah, once it says self-test rev 33, which is what it says there, that means the system is booting. So I'm just gonna let this do its self-test. I won't let it boot into Unix, there's no point, because then I have to do a clean shutdown and stuff. But if this passes all its diagnostics, so we're good to go, and I can unplug the motherboard, take it out, I put the other RAM card in. And I think what I'm gonna do on the other RAM card, where did I put it? Here it is, sitting on the bench behind me. What I'm gonna do is I am gonna flip these switches to the other position, which should disconnect the extra address lines to make this a 2 meg card. So to the computer, it won't see it any different. And if this just works as a 2 meg card, that's a huge win. That means that, well, we have a replica RAM card for the Plexus. Like, that in and of itself is very cool. But then, well, I'm getting ahead of myself. Okay, system is working. It passed its self-test. It sees it has 2 megs of RAM. I don't know if that's visible in the camera, but yeah, it says 2.0 megabytes right there. So let's just turn the computer off using my car theft utility, or implement, I mean. And now I just have to spend a moment, turn this all off to get the motherboard out. And I gotta take all these little adapters off the back. I had left them on there, but all these RJ45 DE9 adapters have to come off because they will not fit through the case because the motherboard has to slide that way so we can get it off. Working on this machine, it's quite serviceable, to be honest, but at the same time, it's not. The motherboard's easy to take out, but there's a bunch of stuff in there that's really hard to get to. The OMTI 5200, the SCSI interposer, that's an example of something that's deep in there, really hard to get to. So to get this out, just have to pop these connectors off. That's the power connector, that is the SCSI connector, 2 thumb screws. That one's out, and now this should slide forward like this. There we go. And then lift out. And then if I rotate this around, on the back side is the original RAM card. And then this has 2 little plastic clips here, and then I gotta release those, and then the card can come off and I can put the new one on. So Bic pen, of course, helps get these little plastic clips off. There's one. Okay. And now I should be able to wiggle this off carefully. Okay. Okay, so that's the original Plexus card. And there's the new card. So of course the problem is I was going to check for a short on the regulator, but I can't anymore. That's fine. I can check on this AT Tiny that handles the reset circuit. And yes, without a doubt, I had to remove that pin header because there would be no clearance. That board is right up against this sheet here. Okay, so 5 volts on the power supply. It's this flying lead right here. That goes to there. And we're good. We are good. So it's beeping, but it's 8.16 ohms. That's exactly what you get. I'm going to remove the card. Oops. Card's off. We will have the exact same resistance between ground and 5 volts with that card removed. Before, when it had the short, yeah, see, 8.18 ohms. Before, when this was shorting out the system, it was 0.2 or 0.1 ohms. So this, I think, did the trick, at least for the short. If it's going to work, I couldn't tell you. Let me just verify one more time that we don't have a short. And there it is. Yeah, 8.18 ohms. So that looks good. Yeah. I don't know what else to do other than try it. Okay, motherboard's in place. Gonna connect up the SCSI cable and power connector. Now remember, it's in 2 megabyte mode. I'm just gonna put this up on the top here. So I gotta plug in the serial to console 0, that slid, since I'll just tighten one of those thumb screws a little bit here just so it doesn't slide around. There we go, good enough. Okay, let's turn on the terminal and just make sure I'm recording. I am. Terminal's okay. So hit enter, and here we go. The moment of truth, everyone. 3, 2, 1. Oh, the power's not plugged in. Yeah, my bad. That was anticlimactic. Power cord not connected on the back. I always unplug it for safety just because I don't necessarily trust those 300 volt DC connections in there. Okay, here we go. 3, 2, 1. Plexus. I don't think it would even do this if we had no RAM. Self-test. Oh no! It's not working. It's not working. So yeah, self-test 3.3, main T4 4001 failure, job failed, map failed. I never actually tested to see what would happen if I powered this up without a RAM card installed. Maybe it actually is able to run these diagnostics without the RAM card, because there is a little bit of static RAM on the board. It's the memory mapper. I can hit delete, and that does delete, or that does get us out of here. Now you can run these tests again. I mean, I can just also try to bypass everything and try to boot the system. But no, it's not actually booting. The hard drive's not doing anything at all right now. I should take the card out and we should see if it will even do this, because this is interesting. It actually gets to the bootloader here, which is very surprising to me. But clearly we got some issues here. Maybe what I need to do is I'll reset this thing. So it's in reset and out of reset. Let's just watch to see what exact errors we're getting, because I canceled out of the diagnostic at this map test here, that delete. So we'll let it run through. Very curious, and I'm kicking myself for not having tried this without any RAM card at all. But yeah, this is obviously not a good sign. You know, what's really funny to me is I would have expected like tests 0, 1, 2, 3, for instance. Mapper, oh yeah, still a memory error. Self-test failed. I would have expected like the earlier tests before 4 to be the RAM test. I don't remember if we have an actual list of what they are. Let's see, we can actually run them. T0, prom. Oh, there we go. Memory size, you see that? It said 0 megabytes. Okay. Well, I'm gonna turn it off, and I'm gonna take the card out, and I'm gonna flip those switches. Maybe it's in the wrong position. I don't know. Now what's curious is there are 3 switches on there, and I just looked at the schematics real quick. One of them, well, 2 of them are for address lines, and one of them is actually a ground input into the UART, or not UART, the glue logic. So what if that is set to the disable setting right now? That is entirely possible. Oh, I can't move the motherboard without taking the thumb screw out. Okay, so there we go. And now it's kind of inconvenient. The RAM card is on the, or facing the wrong direction, so I have to take it off every time I want to flip the switches. Okay, hopefully this is in focus. So the top one is maybe like an enable switch or something. It's in the position that it was in originally. So I'm just gonna flip the other 2. Oh, you know what too, before I put this back in, why don't we try powering up the Plexus with no RAM? I just wanna see if the errors we were getting there is exactly the same as if you have no RAM card at all. Because I don't think I've ever tried that particular test before. I'll just leave the SCSI unplugged. Doesn't really need to be reconnected. Oh, I do need to plug the terminal in though, so we can see what we see error-wise. Plexus with no RAM card. Here we go, 3, 2, 1. Ah, so it does boot without a RAM card. I mean, it gets to this exact point. Wow, it actually failed way more quickly. That's interesting. Notice it just right away went to main and job, and before we saw like mapper fails. But we can still get to the DMA menu, so let's try running the test manually. There we go, 0 megabytes again. Memory parity error. So the error is different. Very interesting. So this is a crash here. Program counter, that's for the CPU and SR. So it's flags and stuff. Okay, bus error. Let's, I'm gonna put the card back in, but the question is, which way do I flip those switches? So I've re-enabled, I think I've re-enabled on. Yeah, I've re-enabled A21 and A22. Now, I looked at the schematics, like I said, so the top switch, it's not labeled, but if you switch it to on, it grounds one of the pins on the glue logic. Whether that's necessary or not, like an enable pin, I don't know. I'm gonna have to talk to Super SVGA to figure that out, but let's just try it this way. Let's just see if this does anything. I don't know if it was designed necessarily to work as a 2 meg card. I mean, it should work either way, no matter what. If you don't hook up those address lines, it's just, you're gonna have mirroring, that's all. But it is curious to me that having the card in there is different than having no card. It's kind of cool to see that the computer can boot a little bit with no card. So either the ROM routines are designed in a way that allow it to use the mapper memory, or maybe it's just these are ROM routines that can run without any RAM at all. Plexus with 8 megs of RAM. Hard drive's not connected, but the power is. Let's see what happens now. Plexus self-test. All right, similar. Main and job failed. But this is where it's different, because before it just would fail immediately, self-test fail. Now it is trying to use the memory mapper, or test it at least. Let's exit out and we'll run the test manually, T0. So yeah, it still says 0 megabytes, and now we're getting all this addressing error stuff. I think what's happening is it's trying to talk to the RAM, and this is failing. DMA interrupt, expected, failed. Doesn't say parity error though. That's interesting. Of course, there is no parity. Yeah, DMA interrupt, mapper failed. There's no parity on this card because it's an SRAM chip. I assume the glue logic is trying to recreate the parity checking or something like that. And maybe not having the card installed at all results in that parity error, so it's able to detect that line as floating or whatever, but it's not floating at this point. All right, well, my assumption is here we're just gonna have the same failures. The only thing left to try is to switch that other switch, switch 1, and that grounds that input on the chip, and let's just see what that does. Maybe that somehow changes the mode or makes it happy, or I don't know. I don't know. Now the fact that the firmware is programmable, because you saw that there was the programming header on there, means that, you know, those equations could be fixed if the only issue is something with the logic, and it's not necessarily a problem with the actual design of the board. So gotta get this off. There we go. I have to do it all one-handed. And I'm gonna flip the top switch, switch 1. Okay, oh dear. We're gonna definitely keep this in place, this little card, because that keeps the chips and stuff away from the main board. Okay, moment of truth again. Last try. All the permutations have been tried, so it's either gonna work or it's not gonna work. And I'm not holding out a lot of hope. But who knows? Maybe it'll do the trick. No, right away, same thing. In fact, we'll know if the card is totally disabled by flipping that switch. If this shows that, I think, oh no. This actually is the same. Because last time without the card installed at all, we didn't even get this map error. Now we can run the tests again. Yep, 0 megabytes right there. I think that looks the same. I think, yeah. Yeah, I'm pretty sure that this is like it trying to write to the memory and it gets back something that it doesn't expect. All right, well, unfortunately, we do not have an 8 megabyte Plexus P20. We don't even have a 2 megabyte Plexus P20. Well, we do if we put the original card back in, but this card does not work as it sits right now, whether it's a glue logic problem or a design of the circuitry problem. It's probably a glue logic problem, which means a firmware update on the RAM card could fix it. The problem is, without reverse engineering how the original RAM card works, I don't really see a way to kind of get to the working logic. The RAM card here, the original one, as you can see, this is all the memory, but look at all this TTL logic. Part of the logic is definitely for parity because there are 9 chips in the banks. And if you notice, there are 8 banks of chips, so that's the 2 megabytes total. So the parity memory checking is happening on here. We have delay lines and stuff as well. The issue really is the rest of this, the logic about how it connects and how these delay lines come into play. That's going to be harder to replicate without doing all that reverse engineering work on this. I don't think we ever got schematics for this board either. While there are schematics, or at least, you know, text version of it for the main board, I don't think there is for the RAM board. So I think there's really no way to reverse engineer that pretty easily. And in case you haven't seen the last video on the Plexus on the main channel, I'm going to be donating this computer to the Interim Computer Museum up in Seattle. So it's going to live there permanently. So that means if Super SVGA wants to try to get hands-on and maybe reverse engineer this, it would be possible. It's just that they're going to have to go up to Seattle and spend some time in the museum there and try to figure out, what's going on with the logic equations and stuff like that. By the time you see this video, I think VCF in Seattle will be coming up very, very shortly. And that means this machine will be with me up there, and then it'll be there permanently. And you won't see it sitting here on the bench anymore. So anyhow, that is it for the Plexus video series, all of them. And thank you very much, Super SVGA, for trying out to make a RAM card. And I'm kind of bummed. I was kind of hoping flipping the connector around would have fixed it. I mean, it's kind of working, but obviously the logic stuff, I guess, is not working. And that leaves us with a machine that still is just stuck with 2 megabytes, which is very limited. 8 megabytes would have given us so much more RAM on this to try to, maybe port a new version of Unix to it, a more capable one with PPP and a network stack. So we could have, you could telnet into it, obviously over a serial connection. So it'd be kind of slow because there's no, well, unless someone comes out with an Ethernet card. And in fact, I think the multi-bus cards that this thing has had an Ethernet card for the other Plexus, the older models, which had a bunch of cards. Anyways, that's going to be it. Thanks for watching, and thanks to my supporters. Thank you to Super SVGA. Thanks to all the community people who helped me get this machine working. And I hope to see you in VCF, where you can see this machine actually operating and maybe like play around with it. And yeah, that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.